Hello guys, welcome back to this channel, and please remember to watch part 1 of our IPRAN series where I introduced the end-to-end IPRAN architecture, which will help you in better understanding of part 2. Today I will be introducing different IPRAN topologies, and my focus will be on how nodes in different sites, whether access layer or aggregation layer, are physically connected to each other to ensure end-to-end connectivity. As mentioned in our part 1, a service provider network have so many sites in remote locations, and we need to ensure there is connectivity between all those remote sites and their controllers, which are normally deployed in a central location. The remote access sites need to connect to aggregation nodes, and the aggregation nodes also need to be connected. And as we know, it's not possible to have direct connection for all the sites. We can't have fiber from all access sites to the aggregation nodes, and similarly we can't have fiber from all aggregation nodes to other aggregation nodes. So some sites normally will be connected to other sites, which eventually connects to the aggregation nodes, and then the aggregation nodes can also be connected to other aggregation nodes and finally connects to the controllers. So we need to find a way of connecting or ensuring there is connectivity all the way from the BTS to the controllers. And the physical connection between the sites can either be dark fiber or even DWDM, depending on the options available or the business requirements of the service provider. So there are different ways in which we can achieve this connectivity. The first is through Spur connections, where, as you can see in the diagram, we have sites connected directly to the aggregation nodes. So each site has a direct connection to the aggregation node and forming a star or a Spur topology. And this is not feasible because we can't have direct fiber from all the sites to the aggregation nodes. And even if we have all the fiber to the aggregation nodes, this will be a single point of failure. The SG will be a single point of failure. Once we lose the SG, then we are losing all the sites that are depending on the SG. So this is not preferred due to the single point of failure issue. Another option is the chain topology. As you can see in the diagram, we have sites connecting to other sites. For example, as site 1 connects to SG, then site 2 connected to site 1, site 3 connecting to site 2. And we can have many sites connecting to each other to form a chain topology. The chain topology and the Spur topology have same challenge. We have many single points of failure. If we were to lose SG01, then we are losing all the sites that are depending on SG01. And if we were to lose site 1, we will lose all the sites that are depending on site 1. We lose site 2, we also lose site 3, and any other dependent of site 1. So this is also not preferred in a service provider network. The most preferred topology is the ring topology, which has multiple paths. Like we have protection path for the traffic. We have redundant path for the traffic in case of failure. If we were to lose a fiber in one of the directions, the traffic from that side can be forwarded to the other direction. If we were to lose one node, for example, if we were to lose SG01, the traffic can flow backwards from site 1 to site 2 to site 3, then to SG02. So we have protection path or redundant path for the traffic. Hence, it's more preferred by service provider networks. The most common topology is the hybrid topology. As we said before, we can't have only rings in our network. Sometimes we end up having Spur sites, sometimes we end up having chain. So as much as the objective is to have a ring topology, we end up having a hybrid topology. Because first it has to start, maybe it could start as a Spur topology or a chain topology, and then when we have new fibers provision in the network, we end up with a ring topology. So generally the hybrid topology, the most common in service provider network, you will have the Spur, you will have the chain, and then you will have a ring topology. So these are the 4 ways in which we can achieve connectivity for the IPRAN network: the Spur, the chain, the ring, and the hybrid topology. Thank you for watching, and please remember to subscribe. Thank you.